Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 4 and sequencing the series. And this is the lecture number 24. We're going to talk about the Taylor and the Maclaruin series. We're going to take several videos to cover the lecture number 24. Okay, so let's go ahead and go to our lecture notes and start the part 1 of this lectures here. Okay, so for the lecture number 24, we talk about the Taylor and the Maclaruin series. So for the first part here, so part number 1, we're going to take a look. The key concepts here we're going to take a look is the definition, of the Taylor and the Maclaruin series. Okay, and then the next things here we're going to talk about in the part 1 here, we're going to talk about how to construct the Taylor and the Maclaurin series. Okay, from the basic series here. Okay. And then for the next part, we're going to talk about we call it the Taylor polynomials, and then call it remainders of the Taylor series. But for this part number 1, we're just going to start out very basic. We're going to talk about the definitions of what do we define and how do we mechanical construct it. Okay, so in here I have give you a table. Those are some very basic Maclaurin series, and it's easy for you to derive it after we talk about how to construct. And the reason why I put it in here is just kind of a summary, a good reference tables here. So you don't have to, if you need to use those special Maclaurin series, for the function, you can just take a look. You don't need to re-derive it every time. Okay. Okay, so now let's take a look at what is the definition of the Taylor and the Maclaurin series. Okay, so in here we say not every, so it's not that every function can be written as power series, all right? Written as a power series. But, okay, however, okay, however, if a function y is equal to the f of x can be expressed as a power function. Okay, power series. Okay, in x minus a, then the series has the form okay, so we can write the f of x equal to summation n from 0 to infinity. Then here is f of the nth derivative of the a, and this is n factorial, then the f of x minus a to the nth power. Okay, so this is what we call this the Taylor series here. And then the f of the n to the so f of the n is what? F of the n of the a is the nth derivative. It's the nth derivative of a, the nth derivative of f of x at a. Okay, so when the A equal to 0, then we call this series, then it is called Maclaurin. It's a Maclaurin series. That means the Maclaurin series when A equal to 0, that means you can rewrite f of x equal to summation n from 0 to infinity. Then this is n factorial. This is f of n to the a to the x factorial here. All right. So then this ones here we call it is the Maclaurin series. As you can see, the table I provide you, those are few very basic Maclaurin series to represent the function, some very common function like 1 minus x, ex, natural log 1 plus x, sine, cosine. As you can see, the x here is all the x to the nth powers, right? It doesn't have x minus a. So the Taylor series is like you expand according to any real number a, but the Maclaurin is a is equal to 0. That's what is the, that's what is we call this the Taylor and the Maclaurin series. It's very, very powerful, right? As you can say, it's not every function can be written as a power series, but if you can read it, you can always try, written as this way. All right, so let's take a look and how do I mechanical construct a Maclaurin series or the Taylor series here. Okay, so now in here we say find the Maclaurin series for the f of x equal to 3 to the x. And typical, I will recommend students try to do so will be a very like do a tables here, right? Okay, so you start with n equal to 0 because our definitions, right? Then n equal to 1, n equal to 2, n equal to 3, and then da. And then hope you'll be able to see some some of the patterns here, right? And then the second terms here, this will be the derivative. All right, so like the first one's here, right? So let's take a look at what I mean. Okay, so n equal to 0, that means you not take any derivative, so it will be what? It's the 3x here, all right? After you get that, then the next thing's here, you will plug it in f of n to the a's here. So for here, because it's Maclaurin's, right? Because it's Maclaurin, so what is my a's here? A is 0. Okay, so you'll plug into the 3 to the 0. This is equal to what? Equal to 3, right? Okay, now after that, then the next things here you will put is the n factorial, because based on our formula, we have a factorials, right? So in here, the n factorial, n is equal to 0. 0 to the factorial is what? 0 to the factorial is it's ones here, and then the last columns here, let's try to put, remember the definitions here, right? Is the n to the nth derivative and n to the n factorials, right? So let's try to put these ones together. So this will be f of the n's, the a, n factorial x to the n, because it's Maclaurin. So n is equal to 0. So the I'm sorry, here 3 to the 0 equal to 1, right? Okay, so then this will be 1 over 1 to the x to the 0 factorial. So this is 1 over 1 x to the 0 factorial is 1, right? Okay, so now the next things here, let's take a look at the f prime x. So you take the derivative. So I know the f prime x, this is the function 3x, but then you need to adjust the constants. So it's natural log 3. So now you put the a to here. So this will be the 3. So the 3 to the what? 3 to the 0 and natural log 3, right? So this will be what? It's a natural log 3. And then n factorial, so what is here? 1 factorial is 1, right? So now let's put it in this form. So it will be what? It will be natural log 3 over 1 to the x to the first power. So it will just be the natural log 3 x to the first power. Then after a few turns, you should see the pattern. Okay, so now let's do the second derivative. So this is still is a 3x. You adjust the constants. You need to take another natural log 3 here. So it's square. Then you plug the number in. So it's 3, 0. This is a natural log 3 to the square. So it's a natural log 3 to the square. Okay, n factorial will be 2 factorial is equal to what? Will be equal to 2, right? So it will be equal to 2 here. So now I can have here, so I will say this is a natural log of what? 3 to the square. Then I have a 2 factorial, then x to the square. Okay, let's try to do one more. Then we can get a good idea. N equal to 3, so you take the derivative about the 3x again. So you need to adjust the 3. So right now it will be 3, right? Then you put the 0 into the, so it's 3, 0, natural log 3 to the 3. So you will have natural log 3 to the 3's here. So what is n factorial? Is 3 factorials, right? Okay, so now let's put it here. So this will be 3 factorial natural log 3 to the third power x to the cube, right? Now you can da 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 da. Then your answer of that will just be you add all those terms together, right? Okay, so now if you see the pattern, so I will see the pattern. So I will say that f of x, if I add this term together, right? So it will be summation n from 0 to infinity, right? So you see 1, this is a natural log 3, the x, the natural log 3, the square, 2 factorial x squared. Natural log 3, the 3 factorial x squared. So what is the patterns here? It will be the n factorial, right? So then this is the natural log 3 to the nth power to the x to the n factorial. Okay. All right, so now let's take a look for these ones here. What is the domains here? Okay, so by the by the expansions here, I know that in order to find this is the series, right? So f of x, so I know the 3x can be written as this. Then in order to find the the domain or the interval of the convergence, so what do we use to? We use the ratio test. Right, so we say the limit n approach to infinity. So the top is an plus 1 to the an, right? That's what is the ratio test. So we say n approach to the infinity. So what is the an plus 1? So this will be n plus 1 factorial and natural log 3, the n plus 1, then x to the n plus 1, and divided by n factorial natural log 3 to the n, x to the n's, right? We want this one's what? Less than 1, right? In order to be convergence here. Okay, so now in here, you can take a look here. So now you can flip it. So this is natural log n approach to infinity. And this will be the n plus 1 factorial natural log 3, the n plus 1, then x to the n plus 1 times, this is the n factorial natural log 3 to the n, the x to the n. All right, now you can say that here I can cancel this one out. So I have x left here. Then I can cancel this one out. I have natural log 3 left here. Then for the n factorial, n plus 1 factorial, so this ones here will be limit n approach to infinity. You have natural log 3 here. Okay, so always, okay, so natural log 3 here, I have x. So what is n plus 1? So we said a factorial use ratio test is super good, right? So n plus 1 is what? Is n plus 1 times n factorials, right? So this one can cancel. So what do you have here? You have n plus 1, okay? And then in here, you can set this one's here, you will have a limit, then approach to infinity. This is natural log 3, n plus 1, the absolute value of x. And then you will say, hey, this one here is natural log 3, is a constant, right? Then when n go to the infinity, this number going to where? This number going to 0. So the whole thing is what? The whole thing is going to zeros, right? So it's always less than 1, see here. So we know the radius of the convergences here R is infinities, right? So that means, that means the 3x. So that means I can write that the 3x equal to summation n from 0 to infinity, n factorial natural log 3 to the n xn for what? For all the value of x. Okay, so that means the domain of the x here, we can write it as for all the value of the x here. All right, so this is a very mechanical way. Like I said, I typically like just to do a table. So when you do a table, the chance for you to make a mistake is pretty small here because it's a very organized way, right? Okay, let's try to do one more example here. So for this example, is we try to find the Taylor series for the f of x equal to 1 over x here, right? And with a equal to 1. Okay, so now let's take a look here. How do we do this ones here? All right, so in here, we do the same things, right? So this is my n. So I have n equal to 0. Then I have this is the derivative of my n. Then I have this is after I take the derivative, I substitute to my a's here, right? So that right now the a equal to 1. So I substitute to a's here. And then in here, you will have your n factorials, right? Then the last ones here, you will be able to put this together. Okay, so now let's take a look here. All right, so the f of x, n equal to 0, that means I'm not taking the derivative. So this will be 1 over x. Probably will be easier. I write it as an x to the negative 1. Then I'm putting the a right now. What is the a values here? A value is 1s, right? So I put the 1s here will be 1 over 1. So it's 1. Okay, so this is 1, and then the n factorial is 0 factorial is 1, right? So you plug in here, the first term is 1. All right, then now I have n is equal to 1. That means you take the first derivative. So this will be negative x to the negative 2. All right, so this is negative x to negative 2. Then you plug the 1 in, so that this will be negative 1 to the negative 2. So this what happened here? This will be the negative 1. So what is the n factorial is 1 factorial, right? Okay, so 1 factorial. So what is over here? So this will be negative x minus 1 to the first power, right? Okay, so this is x minus 1 to the first powers here. Okay, now let's take a look at the second one. Okay, so this one is n is equal to 2. Okay, so when you equal to 2, so this one's here, you will be 2 to the x to the negative 3. Right, so this is 2 to the negative 3. Then the f of 2, okay, so you plug in 1. So this will be 2 times 1 to the negative 3. So this is 2. And my factorials here is 2 factorial. So 2 factorial and 2 is the same. So that's why here I'm going to have f of a is 2 over 2. 2 over 2, right? Then the x minus 1 to the square. So this is x minus 1 to the square. Okay, so we start to notice this is look like an alternating series. So we might need to have a few more terms so it can help us. So n equal to 3. Okay, take a look here. So the 3, you take the derivative is 2 times -3 to the x to the -4th, right? So now you plug the 1 in here, so will be the -2 times 3 times 1 to the -4. So will be -2 times 3 will be 1 times 2 times 3. So this one is here, the 3 factorial. Now in here, n factorial, this is 3 factorial. Then you say, oh my gosh, this one cancel out. So it's very good. So this will be what? This is the 3 factorial over 3 factorial, then x minus 1 to the 3rd. So this will give you negative x minus 1 to the cube, right? So let's take a look one more. So to confirm our suspicions, n equal to 4. Okay, so then you move the 4 down. So this will be what? N equal to 4 when you move the 4 down, right? So this will be negative. So it's 2 times 3 times 4, x to the -5. Then you put it in here, so this will be the 2 times 3 times 4. So this will be what? It's 4 factorial. Then n's here, n factorials here. This is 4 factorial. So here I'm having is 4 factorial divided by 4 factorial, x minus 1 to the 4th. So will give me x minus 1 to the 4th. Okay, now I see the patterns, right? So I will say 1 over x here. Okay, so I will say 1 over x, I can write it as a summation n from 0 to infinity. And then you also notice here, this is alternating series, it's negatives, right? So negative and odd and the positive at the even. So you can write as this. So you will say this one's here is alternating. So I have a -1, okay, to the nth power. So when n is equal to 1, this is negative. When n is equal to 3, this is negative. Good. And then here, the f of n, you will get is the n factorials, right? And then the bottom here is also is n factorial. So that's why you cancel. So if you want, because you already see the pattern, you don't need to write this. So this will be, so then this one's here, you say, because well, like I guess a better right here because you cancel each one other out, right? So you will say here, this is -1 to the n. So what is this one here would be x minus 1 to the what? Nth power, right? So that is, okay, so that is what is the Taylor series expansion for that. Okay, so now let's take a look at the convergence, the interval of convergence is here, right? Okay, so we use the ratio test again. So we said limit n approach to infinity. So the top will be -1, the n plus 1. This is x minus 1 to the n plus 1. This is an, so -1. This is x minus 1, the n is less than 1 here. Now we can see here this one's cancel. So this will be the x minus 1 less than 1 here. Okay, so that means this one's here will be x is less than what? Less than 2 and greater than 0. Okay, so now we know that, okay, so now because we use the ratio test, so let's try to check the endpoint, right? So we say when the x equal to 0, when x equal to 0, your 1 over x is equal to what? N from 0 to infinity. So this is -1, -1. So it will be summation n from 0 to infinity. So this is -1 to the 2n's, right? So this is summation n from 0 to infinity to the 1. So this is a divergence. right? Because limit an, since because limit n approach to infinity to 1 is not equal to 0, right? Now I can check when x equal to 2 here. So when I check x equal to 2, and then I have 1 over x is equal to the summation n from 0 to infinity, and then this one will be negative 1n to the 1 to the nth power, and this one's here is a divergence also, right? Because this is alternating series, it's the same thing. The limit n approach to infinity, 1n is not equal to 0. So it's a divergence. So where is the series, the interval of the convergence here? The interval of the convergence will be what? Will be 0 to 2, not cover the endpoint. That means I can write the f of x equal to the 1 over x by a Taylor series expansion only between the, only in the interval of the what? Only in the interval of the convergence. All right. Okay. So now let's take a look one more. Okay. So let's like to go to do the number 4 here. All right. So for the number 4 here, I said find the Maclaurin series for the E equal to f of x equal to the e to the 4x. Maclaurin series again. So what's that mean? That means a is equal to what? A is equal to 0, right? So let's try to do this one more time. So this is n equal to 0, n equal to 1, n equal to 2, n equal to 3. And let's take a look. We can see any pattern. So when x equal to n equal to 0 is not take any derivative, so it's by itself. All right. So this is fn. You plug in 0, so e to the 0 is equal to 1, and then this is n factorial. So I know 0 factorial is 1. Then here, this is my final form. Is f of the n, the 0 n factorial xn. So this will be 1. Okay, now f prime, that means you take the derivative. So it's a 4, so it will be e to the 4x. Then the chain rule will give you 4 here. So fn's here, you put a e0 is a 4 times e to the 0 is 4. Okay, so this is a 4. And then here, what is here? This is 1 factorial, right? Okay, so this is 1 factorial. So what is this term going to look like? This is going to be look like a 4, 1 factorial, and x to the first power. Okay, let's do a few more terms to see we'll be able to see the, the patterns here. So if you take a look at the derivative again, so it will be the e, the 4x, right? But don't forget the chain rule again. So what do you have here? 4 to the square. Then you substitute the a equal to 0. So what you have here? 4 to the square. What is n factorial? 2 factorial. Oh, well, I see a pattern here. So now I plug in here. So this is a 4 to the square, 2 factorial, x to the 2. Let's do one more just in case. All right, so if you take the third derivative, this is e to the 4x. Then you need to do the chain rule again. So this is for the cube. Okay, so now for the f of n to the 0, so this is a 4 to the cube, e to the 0, so this is a 4 to the cube. Then the n factorials here, what is n factorials here? N factorials here, this will be 3 factorial. Well, pretty good. Seems it's match my patterns here. So this will be 3 factorial, 4 to the cube, x to the cube. Okay, so now I can rewrite this f of x equal to the e to the 4x here. Okay, so e to the 4x, I can write this one as summation n from 0 to infinity 4n, and this is n factorial x to the nth powers here. Okay, and now we can find the level of the convergences here. So I use the ratio test. So you will see limit n approach to infinities, right? So the ratio test here, you can put here, this is n plus 1 factorial, 4 to the n plus 1, x to the n plus 1, and this is 4 to the n factorial, x to the n, right? We want less than 1. So you will have the limit n approach to infinity. So this is n plus 1 to the 4 to the x is less than 1. It's just like we did before. What is this terms here? This term will approach to 0, right? So you're going to have 0 less than 1. So it's true for every, so it's true for every value, right? So I know I can f of x equal to the 4x. I can write into this series, right? N from 0 to infinity, 4n, n factorial xn for all the x, okay? And then the last things I want to see here, because this is e to the 4x. At the beginning, I show you, I say, hey, take a look here, right? This is the common, like the very, very beginnings, right? So this is the common Maclaurin series. So as you can see here, right, for the EX is equal to 1 plus, so this is the formula xn to the n the factorial. So now you have e to the 4x, right? So now you have e to the 4x. So what you can do, you can use the existing series you just said here. So this is from n from 0 to infinity. Then this is n factorial. So your 4x, right? So you replace with the x here. You see here? Okay, so now that's why you can have a 4x to the nth power. So you will, so this is n to the infinity. So this is n factorial 4n to the xn. It's exactly the same like we just got. Okay, so that's why the reason why I give you this table, right? So like for some like the functions here, you don't need to rederive it. If it matches some existing Maclaurin series, you can just plug that one in and then find the series. Also, as you see here, right? So in here we said for this series, you can do the Taylor series, you can do Maclaurin series expansions for all the real numbers here. So it's the same conclusion like we did. Okay, all right. So this is the video number 1 for the part 1. Then we still have a few more problems. So let's take a break here, and then we'll come back to here to finish the second part. Okay. Okay. So nice to talk to you, and looking forward to talk to you in our next videos here. Okay. Bye bye.